Welcome viewers. In this video we'll see the accessories required for the wiring. Subscribe this channel for the electrical videos and electrical materials. The material for this topic available in the drive. The drive link is given in the description box. Now we'll see the first accessory, cable. Cable is the important parameter for wiring. So the cable is made up of two conductors, that is the conductor and insulator. There are various types available. Normally we are using copper conductor or aluminum conductor. The main conductor are described according to the insulating material used. Based on the insulating material, we can classify this cable. So the cable is the important thing that is conducting the current. Normally we are using copper conductor or aluminum conductor. Then these conductors are classified based on the insulating material. There are three types available. We'll see the types one by one. First one, VIR, vulcanized Indian rubber cable. So VIS called a VIR. This cable consists of tint copper wire with a layer of vulcanized Indian rubber insulation. So the cable is available, conductor is available, over which this VIR is given, vulcanized Indian rubber insulation. Second type is the TRS or CTS cable. So this TRS or CTS means, TRS means tough rubber sealed, tough rubber sheathed, or CTS means cap type sheathed. So it is the same as VIR cable with an additional layer of insulation with tough rubber. It is similar to the previous type, but what we have, one more additional layer with the tough rubber is available. This type of cable mainly used in factories. In order to withstand the high current, we are using one more layer of insulation with the tough rubber, so that it is used in the factories. The third type is PVC, polyvinyl chloride cables. So this type of cable consists of polyvinyl chloride insulation. So the insulation is given as a PVC, polyvinyl chloride. It can be two types, single strand and multi-strand conductor. It may be a single conductor or multiple number of conductors available. So based on that we can see the classification. The cable, we have conductor and insulator. The cable consists of conductor and insulator. The conductor may be aluminum or copper, aluminum conductor or copper conductor. The copper again two types, single strand or multi-strand. Single strand means only one coil will be there, multi-strand means n number of coils will be available. Then based on the insulator, it is divided as VIR, CTS or TRS, or PVC, polyvinyl chloride. So Indian rubber, this is a tough rubber sheet. This is a polyvinyl chloride. Now we'll go to the second accessory. The second one is the switch. The switch is used to make or break an electrical current. It is used to connect or disconnect the supply to the any equipment, any apparatus. We are using the switches. So that is used to make or break the electrical circuit. Then third one is the main switch, ICDP. What is ICDP? Iron clad double pole switch. So it's a main switch. This switch is used for the various parameters, bulb or tube light or fan, like that. This main switch is the main from the main supply, EB supply. So it is the most important protective device in the electrical installation. So the main switch is the important protective device. Then ICDP is nothing but iron clad double pole switch. It's also called as a main switch. The content of IDCP is one number of fuse carrier, one neutral bar loop link, and mechanical make and brake system is fitted inside the metal cabin. So this ICDP contain the fuse carrier, neutral bar link, mechanical make and braking system. So it is connected in the main, available from the EB main. From this only the supply is given to various rooms. So that is given here. The outgoing wire of energy meter are connected incoming portion. So this main switch, the incoming is coming from energy meter. Then outgoing is connected to the distribution box. From this distribution box, distributed to various rooms or various areas. So this main switch contains the fuse, neutral bar, mechanical support and braking system. The incoming from the energy meter is connected, outgoing from the meter is connected to distribution box. So from this main switch, the supply is distributed to the various distribution boards. Then we will see what is meant by the distribution board. In an electrical installation, large number of wiring points are connected. Suppose we want to electrify the one house or one apartment, there are n number of installations, the n number of wirings are available. Going to the kitchen, bedroom 1, bedroom 2, main hall, veranda, like that. So in order to control these points into separate circuit, so this distribution box will distribute the cable to all this veranda or bedroom separately. Separate circuits are given through this distribution box, so that we can easily identify the wiring, which one is going to the bedroom, which one is going to the main hall, kitchen, like that. So this is distribute from the main supply. This distribution board will distribute to each and every point. In this distribution board, the points are separately controlled by different circuits. So each and every room will be controlled separately. If you want to maintenance the bedroom 1 means that alone can be controlled by separate switch. Then the types available: flush type DP with flush fuses or isolator with MCB. Flush type DP means flush type with the flush fuses are available. Normal fuse, if any abnormal condition, the fuse will glow, what we are normally using in the household. The thin wire will be the fuse, there's a flush, it will be flushed. If any abnormal condition above, it flushed. Another one, isolator with MCB, miniature circuit breaker. Is a fuse mean if fuse will glow, we need to replace the new fuse. Here is a circuit breaker. The circuit will be braked based on the gravity control, the bimetallic available inside, it will break. Again we can reconnect. No need to replace the fuse here in case of MCB, but here we need to replace the fuse. Then we will see what is meant by fuse. A fuse is used to protect an electrical device with a high current flow through the circuit, that is more than the capacity. In a electrical equipment, if the more amount of current, that is more than the capacity of the device will flow, means automatically the fuse will glow. It will disconnect the equipment from the supply for the protective purpose. Then we can replace with the fuse, and we can see why the high current is flowing. We need to rectify any fault is there, we can rectify. So this fuse will protect the electrical device by flowing the huge current, so that it will burn out, so that it will not allow high current to flow in the electrical device. It will disconnect. Now we will go to the next type of accessories. The sixth one is the plug and sockets. The socket will have 3 terminals, terminal slave. The 2 thin terminal used for phase and neutral connection. The third terminal slave used for the earthing connection. The 3-point plug, that is called as a 3-point plug. In that, one plug used for earth connection, it will be bigger size. Another 2 thin terminal used for phase and neutral connection. So this is a plug and socket. From that we can get the supply. It can be by using this plug and socket, the various accessories can be connected. TV, radio or any other mobile, anything can be connected. We can take the supply from this jacket. Then lamp holder. The lamp holder are used to fix the incandescent lamp or CFLs. It is the holder. It will hold the lamp, either CFL or incandescent lamps. The types are pendant, steady or angle batten. There are various types of holders are available. Then sealing rose. Next one is the sealing rose. The sealing rows are used to provide a tapping to the pendant holder, fluorescent lamp or ceiling fan, wall fan or exhaust fan. So it is the name itself. Sealing rows means it is connected in the ceilings in order to provide the supply to these various equipments, either a pendant holder or fluorescent tube or fan. The sealing rows consist of a circular procline or backlit base provided with 2 or 3 terminals. It is nothing but a plastic material. So each material has one outgoing and one incoming screw holes. So it will provide a supply to the various equipments, tube plate or fan. It is connected in the sealing rows, means it is connected in the ceiling. Then we will go to the breaker. Earth leakage circuit breaker. Earth leakage circuit breaker, ELCB. So it is a protective device which will automatically trip. Trip means disconnect when there is an earth leakage in the installation. So we already used the fuse or MCB, that is used when excess current is flowing through the equipment. This one used due to earth leakage. If any earth leakage is there, this circuit breaker will protect the equipment by tripping or by disconnecting. It is also known as earth leakage circuit breaker. It works on the current balancing principle. There are 2 coils with the same number of turns winded on a magnetic core. It carries phase and neutral current which are the same. So it has one coil is available. 2 coils are available through which phase and neutral is connected. This carries the phase current and neutral current. We will see what will happen if any abnormal happens. The magnetic flux produced by the coil is in opposite direction, hence different in the coil. So the flux produced will be opposite. If there is an earth leakage, the phase and neutral current different in the coil. So due to any earth leakage, the current in the both coil will differ. So the flux induced in the coil and activate the trip current. So if the fluxes are equal, there is nothing will happen. If any earth leakage, the difference in flux will occur, difference in current. That current will produce the EMF, produce the flux in the coil. That flux will attract the contact so that the circuit is disconnected. So it has the earth breaker having 2 coils. For normal condition, both the coil will carry the current and also it is equal. So there is no flux. If any abnormal condition or earth leakage, there is a difference in the current. Due to the difference in the current, flux is produced. That flux will induce the EMF that will attract the contact so that it will be disconnected from the circuit. Then we will go to the other terms: junction box, T, elbow, bend, couplings. So these material are used to run over the pipe as the layout of the supporting wall. Right? So through this junction box or elbow, the wiring is given. The bend is used when we want to turn the wiring. Saddles are used to fix the pipe on the supporting wall. So these materials are used to run the wires in the ceiling. Then MCB, miniature circuit breaker. It is a compact device used in the distribution board for protecting against the overload. This is achieved by thermal trip mechanism using bimetallic strip. We already discussed the fuse. The thin wire will be there. If any abnormal condition, the fuse will be glow. That will disconnect the circuit. Thereafter, we need to replace the fuse. But by using the MCB, no need to replace the fuse. It is based on the thermal. It is based on the thermal mechanism. So if any abnormal condition is there, the heat will be produced. That will trip the circuit automatically. So no need to replace the fuse. So it is based on the thermal mechanism bimetallic strip. During abnormal condition, the excessive current will flow. That will create the heat. Due to the heat, the bimetallic strip will be activated. That will disconnect the circuit. When there is overload in the circuit, within few seconds, trip mechanism is activated. Electrical insulation circuit is disconnected. Right? So the inside bimetallic strip is available. That will work based on the thermal principle. When excessive current or voltage is there, that heat will be produced. This bimetallic strip will disconnect the entire circuit for the protection purpose. Then cutout fuse. The last one is the cutout fuse. It should be inserted where it is necessary with the regard to the load capacity of the line. So the cutout fuse mean if you connect any equipment, if you want to take 10 ampere mean we can connect 10 ampere fuse. So that it will allow only 10 ampere. If the excessive ampere above 10 ampere, 11 ampere mean it will disconnect the circuit. So that equipment can be protected. A cutout fuse connected in series with the load line also protect the smaller cross section against the overload. This is used for particularly used for any equipments. Right? The MCB, other things used for the entire circuit. This is for any special equipment we need to protect, we can connect through the cutout fuse, so that this cutout fuse will not allow any excessive current. It will disconnect and protect the equipment. Now we'll see the circuit breaker. One more circuit breaker is available. Line protection circuit breaker. So entire line is protected by the circuit breaker. The previous one is based on the equipment. It is thermally delayed overload release and electromagnetic quick acting release. So based on the electromagnetic as well as thermal, because it current stability in the overload region and necessary quick action when there is an short circuit. If there is any short circuit is there, immediately it will react and disconnect the circuit for the entire line. It will protect the all equipment, the entire house. So in this video we discuss about the wiring accessories required. Some more videos available related to the wiring. The link is given in the description box. The material drive link also available in the description box. Also subscribe this channel for more videos and more course materials. Thank you. Welcome viewers. In this video we will see the specification of the cable. Subscribe this channel for more electrical videos and course material. The course material link is given in the description box, and video link also given in the description box related to the wiring, electrical wiring. Now we'll see the specification of the cable. So that is classified based on the size of the cable. It is classified based on size of the cable. Based on that we can see what type of cable and what is the maximum current carrying capacity. Right? It is classified based on the size, so that it is classified into type, what type, and maximum current carrying capacity. So first we will see the first type, 1/18. 1/18 means single stranded. Only single strand means only one coil is available. One number of 18 gauge. So gauge is nothing but the dimension for a wire. The gauge. It will give the thickness of the wire, thickness of the cable. Right? So 1/18 means it is single stranded, single coil. Only single coil is available. One number of 18 gauge. So this 1 refers one coil, 18 roughs, 18 gauge. So what is the capacity? This is 5 ampere. It will carry up to maximum of 5 ampere and 230 voltage. The voltage is 230 for all the cables. All the type carry 230. Only the current will differ. So 5 amperes. It will take maximum current of 5 ampere. The second type is 3 bar 20. So 3 means is single stranded. In that 3 numbers of 20 gauge cable will be available. So that is from the number itself we can easily identify. 3 means it is a 3 number of 20 gauge conductor is available. So previous one only one conductor with 18 gauge. Here 3 conductors with 20 gauge. So when the gauge increases, the thickness also increases. Automatically the current also increases. So here 15 amperes. Right. So previously only 5 ampere. Now we have 3 conductors with 20 gauge. So it will able to cable maximum current carrying capacity of 15 amperes. The voltage will be remain 230 voltage. Then we'll go to the third type, 7 bar 20. Again from the name itself we can easily identify it is a single stranded, only single coil. 7 numbers of 20 gauge conductor will be available. 20 gauge wires are available. So the name itself it is available. 7 numbers of 20 gauge. Gauge is nothing but thickness of the conductor. So here the gauge is 20 and 7 numbers are available. So automatically the capacity will increases 25 amperes. So this type of cable will able to carry the maximum current of 25 ampere. The voltage remains same, 230 voltage. Then the next type is 7 bar 16. So this is single stranded. 7 numbers of 16 gauge cables are available. There are 7 numbers of 16 gauge cables are available. So it will carry maximum of 40 amperes. So the 7 numbers available. So automatically it will able to carry 40 amperes. The current, the voltage remains same, 230 voltage. Then we'll go to the next type. So far what we discuss is a single stranded. All are single stranded. The numbers are available. The capacity also given. Now we'll go to the remaining types. So it is given 12 millimeter. The size of the conductor is given 12 millimeter. The thickness or radius. So this is coming under multi-stranded. Multi-stranded means 12 millimeter thickness of n number of coils are available. What we discussed earlier is only one conductor is available. Only one. Now here multi-stranded. So the current carrying capacity is 5.11 amperes. Sorry, 5 to 11 amperes. Not 5.11. 5 ampere to 11 ampere. It will able to carry 5 ampere to 11 amperes. Voltage remains same, 230 voltage. Then 1.52 millimeter. Multi-stranded. Multi-stranded means n number of coils are available with this thickness. 10 to 15 amperes. It will able to carry 10 to 15 amperes. The voltage remains same, 230 voltage. The third type is 2.52 millimeter with multi-stranded. N number of coils will be there. So this will be not 12 millimeter, it's 1.2 millimeter. So when the millimeter increases, size increases, the current increases. Not a 12, it's a 1.2 millimeter. So able to carry 5 to 11 amperes. 1.52 millimeter means 10 to 15 ampere. 2.52 means 15 to 20 amperes. So the size of the conductor increases, ampere also increases. So this will be 1.2. Then 42 millimeter is also multi-stranded. Now see this 2.52 now increased to 42. So current carrying capacity also increases 20 to 25 amperes. It can able to carry up to maximum of 20 to 25 ampere. The voltage remains same, 230 voltage. Then go to the 62 millimeter. It's also a multi-stranded. So we able to carry the current up to 40 amperes. The voltage remains same, 230. So starting from 1.2, 1. This is a standard size of conductors available in the market. So according to our requirement, we can choose any one of these conductor. Whether we need 5 to 11 ampere, this is so up to 11 amperes. Here 15 amperes maximum, 20 ampere, 25 ampere, 40 ampere. We can concentrate the maximum current. What is the maximum current carried by these conductors, right? Suppose if you want to a wiring of 20 ampere means we need to choose this 2.52, or we need 40 amperes. The total capacity what we need 40 amperes mean we can choose this 62 ampere, 62 millimeter. So these are all the standard size available in the market. We'll see the remaining type. 102 millimeter is also a multi-stranded 102 millimeter. So it will carry up to 60 amperes. Able to carry maximum current capacity is 60 amperes. Then 162 millimeter. The size is 162 millimeter. It is also a multi-stranded. Then able to carry 80 amperes. Maximum of 80 amperes. Right. So here the size increases, the current also increases. So in this video we discuss what are the specification of the cable. What are the standard size of the cable available in the market. Then we discuss whether it is multi-stranded or a single stranded. Then current carrying capacity. Based on our current requirement, we can choose any one of this cable for the wiring installation. So subscribe this channel for more videos related to the electrical wiring and other electrical topics. Thank you. Welcome viewers. In this video we will see the description of wiring. Subscribe this channel for more electrical videos related to wiring and other topics, and the course material for this topic available in the drive. The link is available in the description box. Now we'll see the first type, series circuit. The series circuit means consider the resistor. 3 resistors are connected end to end. One end of the resistor is connected to another resistor. So we have 3 resistors, R1, R2 and R3. So the same current is flowing through all 3 resistors. The current will be same. Only one current is flowing through the circuit. Then only it is termed as a series circuit. This is applied voltage V. Based on the resistor value, voltage will be dropped across the resistor. V1, V2, V3. Based on the R1 value, V1 value will be decided. So the total voltage V equal to V1 plus V2 plus V3. The voltage will be divided. The current will be same. So in the series, the resistors are connected end to end so that they form only one path for the flow of current. Then it is said to be a series connected and the circuit is series circuit. The voltage will be divided, current will be same, only one current is flowing. Now we'll go to the parallel circuit. What will happen in the parallel circuit? So when a number of resistors connected in such a way that one end of these resistors connected to common point and other end of this resistor are connected to another common point, then it is known as connected in parallel. Such a circuit is called parallel circuit. Now we'll see the diagram. See, one end of all resistors are connected to one common point. The other end of all resistors are connected to another common point. Then it is given to the supply. So then the supply is given, the current is flowing. So at this point, at one of the common point, the current is divided. I1, I2, I3 based on the R value. Again at this point the current will be combined, the total current will return to the supply. So the parallel circuit means the current will be divided. The voltage will be same. The voltage across the three resistor is equal to V. The same V is available across R3, R2 and R1. But the current will divide. So in the series circuit, current will be same, voltage is divided. In parallel circuit, voltage will be equal, current is divided. So based on that, we can able to understand whether it is a series connected or parallel connect. Now we'll go to the next type of connection. The third we'll see the electrical connection of a lamp. How to connect a lamp. The most of single phase equipment has two terminals. It can be, if we connect phase and neutral on this terminal, the equipment will function. So we have two terminals available. We can connect with phase and neutral so that the equipment will function. For example, if we take the lamp, there are two terminals available. One terminal is connected to the phase, another terminal is connected to the neutral. When supply is given, this lamp will glow. So for any single phase equipment, we have two terminal. One is phase, another one is neutral. When the supply is given, it will glow. Now we'll go to the next type of connection. The same connection, the previous, the switch with, in which the switch is provided in a lamp. Because in the previous connection, when the supply is given, the lamp is glowing always. Suppose if we want to control the lamp, we can connect through the switches. Connect through the switch. So the lamp is available, two terminals are available. One terminal is connected to the neutral. Another terminal is connected through the switch. This is a disconnect. It will connect or disconnect. Switch is the equipment to connect or disconnect. So now it is in the disconnected condition. So supply is not given to the lamp. If it is closed, the switch is closed, the phase is given to the lamp, so it will start glow. If the switch is open, the phase is disconnected. So we can control the glow of this lamp using this switch. The switch is closed, supply is given, the lamp will glow. If the switch is open, supply is disconnected, lamp will not glow. Now we'll go to the next type of connection. So in this connection, the two lamps are independently controlled by a separate switches. The previous diagram, we have one lamp and one switch. Now we have two lamps are available, controlled by two different switches, and also having one plug point, plug socket, right? So we have two lamp controlled independently by separate switches, and here, and we have one more plug point is available. Now we'll see what is the connection, how to connect this. So this is the lamp 1, so lamp 2. So the lamp 1 is controlled by this switch S1. This lamp 2 is controlled by this switch S2. Here we have one plug point is available, socket is available, right? So that three equipments, lamp 1, lamp 2 and one plug point. The lamp 1 controlled by this switch, lamp 2 controlled by this switch. Then how to connect? The phase is connected through the switches. The neutral is connected directly, right? Always neutral is connected through directly, on the phase will be controlled. See, first we will see the neutral connection. See, this neutral is connected to one end. Again tapping is taken from that end. This symbol indicates there is no connection. This neutral is given to second lamp. Again tapping is taken from that. There is no connection. Then it is given to the neutral of the socket, right? So this neutral is connected to lamp 1. Again one wire is run. That wire is connected to lamp 2. Again one more wire is run. That connect to neutral of the socket. Now neutral connection is over. Now we'll go to the phase. This is NL, means neutral line. NL, neutral line. The phase is connected through the fuse. If any excess current is there, this fuse will glow and will protect this lamp 1 and lamp 2 as well as the socket. The entire circuit is protected by this fuse. So the neutral is connected directly. The phase is connected through the fuse. Now this fuse is connected through the switch. It is not connected directly to the lamp. Neutral is connected directly. The phase is connected through the switch. See, this switch is available. When the switch is closed, this phase is connected to the lamp 1. Right? So this is disconnected. This end phase supply is available. If the switch is closed, the phase is given to the lamp 1 so that it will glow. The switch is open, the supply is not given to the lamp. It will not glow. So from this, the tapping is taken. One more wire is run in order to go to the next lamp. So it is not connected, given to the second switch. If the second switch is closed, lamp 2 will glow. If the second switch is open, lamp will not glow. Again, from one more tapping is taken from this switch S2 in order to go to the jacket plug point. So that is given to the phase. So this is the phase, this is neutral. So here the switch is available. So if the switch is closed, then phase and neutral is connected, we can take. And this is the earthing point. Earthing point is run over the entire circuit. Right? So neutral is connected directly to the all lamp 1, lamp 2 as well as plug point. Phase is connected through the fuse and through the switches. Switches S1, if it is closed, then only the phase will apply to lamp 1. Then one tapping is taken, given to S2. Another tapping is taken, given to the plug point. Right? So the lamp 1 is controlled by S1, lamp 2 is controlled by the switch S2, and plug point also controlled. The earthing wire is also available. So in this, we can able to control 2 lamps separately as well as one plug point is available. Important thing, neutral connected directly. Phase is connected through fuse and switches. So that we are able to control the lamp independently. So the N refers neutral line, P refers phase line, NL mean also neutral line, S1, S2 is nothing but the switches to control the lamp 1 and lamp 2. So in this video we discussed about the description of the wiring. Series circuit, parallel circuit, how to control a lamp, how to control 2 lamp and 1 plug point. Subscribe this channel for more electrical videos related to the wiring as well as other topics. Thank you. Welcome viewers, in this video we will see the types of wiring available. Subscribe this channel for more videos related to the electrical topic. The course material for this topic also available in the drive. The link is given in the description box. Now we'll go to the wiring. Wiring system are classified according to the types of wire used in the installation. It's classified based on the wire, what type of wire we are using. There are 4 types available: clad wiring, casing and capping wiring, CTS or TRS wiring, contact wiring. We'll see this wiring one by one. First we'll go to the clad wiring. So it is a temporary wiring method and it is not used for dump wall and ceilings. So temporarily, if you want to go for any temporary wiring, these type of wirings are used. So it has 2 parts available. One is the base, another is the cap. So in between base and cap, the wire is inserted. There will be a center screw hole in these 2 plates and there will be a hole in the base part for the wire to be inserted. So the cap is put over the base part and screwed through the center screw holes on the supporting wall. So the clads fixed should not be exceeding 50 cm. In clad wiring, PVC or VAR wires are used. We will refer the diagram so that you are able to understand easily. So it is a temporary wiring. These type of wirings are used for temporary purpose. See, this is the clad available. So the 2 parts available here, top one and bottom one. This is the screw part. So here the hole is available, in that the wires are placed. The conductors are placed in these two wires, in these two places. Right? The wires are placed, then this top portion is placed and screw is given, so that it become tight. So this is the main part of the plate wiring, having two parts, the top one and bottom one. Through this hole the conductors are placed. So we will see the example. The lamp available is controlled by a switch. So this is nothing but a plate wiring. So this is the phase, the neutral. The neutral is connected directly to the lamp. Phase is connected through the switch. So when the switch is turned on, the lamp will be glowed. When the switch is turned off, the lamp will be in off condition. So here we are using the plate, this portion. This portion is used. So this phase and neutral wire will be held by this plate. So this is a temporary wiring. We cannot use it for permanent purpose, and also it is 50 centimeter. Within 50 centimeter mean we can use this type of wiring. It's a old type also. Nowadays also it is using, depends upon the application. Temporarily if you want to go for a wiring, this type of wiring can be used. Okay, so this is the main part. This part is a plate that will hold the two conductors, and it is tightened so that it will hold the conductors tightly. Now we'll go to the second type. So in this second type is the casing and capping wiring. The type of wiring consists of cable running through a case and fixing a cap over it. So here also two parts available, case and cap. So that is fixed in the wall through which the wire are running. First the case is fixed on the supporting wall by the wooden plugs and steel screws. In wooden type, cap will be screwed on the case. In PVC type, the cap will be locked in the top of the case. So this is one plastic box is available, having the two parts, casting and capping. So through this is a space available. Through this the wires are run. The wires are run through this space available. So first this casing is fixed in the wall. Then the wire is run, over which the capping will be placed. So it's a temporary. This one can be easily removed and easily fixed. There is no screw available. Only the gap is there. So only the casing is fixed on the wall. This capping can be easily removed without any screw. Through the space the conductor is running. So here one model is available. The lamp is controlled by the switch. So this is the casing and capping wiring, this one and this one. So the wires are run through this. The neutral is directly connected. The phase is connected through the switch. So while operating the switch, we can control the lamp. So this is also very simple type of wiring. First the casing is placed on the wall. Then through this space the wires are placed, over which the capping will be placed. Capping can be easily removed and easily placed. So one example is available. Now we'll go to the third type. Third one is the CTS or TRS wiring. What is CTS? Cap type shielded. TRS means tough rubber shielded. These two methods, these two types available. We'll see this one by one. In this method, a well varnished wooden reaper of size 10 mm to 40 mm width is fixed on the supporting wall. So we have the varnished wooden reaper with a size of 10 mm to 40 mm is fixed on the wall or ceiling with wooden plugs and the steel screws. So in the previous method we placed the casing, plastic casing. Here we are placing the wooden reaper. Then a small clip is fixed on the reaper with the brass nails and in an equal distance of 10 centimeter. So the small clip is placed in the wooden reaper at a distance of 10 centimeter. In this clip only we are going to place the conductor. Then wiring is done through the clips fixed on the reaper, and the clips are locked tightly. So in the previous method, the space is available in the casting. In that place the conductor is placed. Here the conductor is placed through the clips. After placing, the clip is locked tightly. One of the main feature of this wiring is that it is a good appearance. It is cheaper than contact wiring, mainly used for lighting purpose. Very easily we can fix this wiring, and also it is good appearance, and also cheaper, mainly used for lighting purpose. So the diagram is available. So this is the link clip and the joint clip. So through the joint clip only the conductors are placed. See, here one wiring is available, model available. So this is the wooden reaper is available. So this is the clip, link clip. So these three lines represent three conductors are running. We can place the three conductors. For example, neutral, phase, earth. These three conductors are held tightly by this joint clip, link clip and joint clip. So this is the clip. This clip is placed, first clip is placed on the wooden bar over which the coils are running conductor. Then the clip is tightened so that the clip will hold the conductor tightly. Right. So the conductor, so first one wooden reaper available over which the conductor is there. Then the clip is hold the conductor tightly. So this is the third type. Now we'll go to the fourth type. Fourth one is the contact wiring. Contact wiring, there are two types available: surface contact wiring, concealed wiring. Similarly, we can use either steel contact or PVC rigid contact. So this is the plastic PVC, this one steel. Either we can place in a surface or concealed. Now we'll see this method one by one. In both two types, PVC or VAR wires are used. In surface contact wiring, the contact are fixed with the saddles by using the steel screw and wall plugs. So here there is like to previous method, here the contacts are placed on the wall. The saddles are fixed at the maximum gap of 1 meter between the two saddles. Suitable bends or elbows are used in the wall on bending. Any bend is available, the elbow or bends are used. The example diagram is available so that you are able to understand easily. If there is a long straight run of conductor, the inspection type coupler should be provided in adequate. So if the length is very long, means inspection type coupler means it is a one box. If any fault occurs, we can open that coupler, we can inspect. What is the what type of fault? Any fault is there, that can be replaced. Because it is a long lengthier, mean it is very difficult to identify the fault. So by placing this inspection type coupler, we can easily identify. PVC insulated multi-stranded cables are used in this type of wiring. So we are using the PVC insulated multi-stranded cables. In concealed wiring, the contacts are buried under the plaster. So we can place this contact either outside the wall or inside the wall. Then nowadays we are placing the PVC pipe inside the wall. Only the switchboard will be appear. All the wirings are available inside the wall, so that it is given. Contacts are buried under the plaster. PVC insulated multi-stranded copper wire is mainly used for this wiring. Copper wire. This method of wiring used for domestic as well as commercial building. So nowadays we are using this type of wiring. Earlier this type of wiring is placed over the wall. We can see all the wiring the PVC pipe, everything. Nowadays it is placed inside. We can see only the switchboard. The wire, elbow, pipe, everything are placed inside the wall. One diagram is available so that we are able to understand easily. So this is a supply available, neutral, earth and line. So this is nothing but a PVC pipe. This is a PVC pipe. So in the bend we are using the elbow or junction points. So this is nothing but a junction point. Here what we need, we need one lamp. We need to divert. Similarly here we are using one junction point because we are using one switch here. Similarly we are using one switch here. So wherever we need a junction, there we can use the junction box so that we can divert. So in this diagram what we have, on the supply line is available, one junction box in order to divert the switchboard, another junction box in order to divert the lamp, then one elbow is there through which another switchboard is available. So we can control this lamp by using these switches. Now we will see the description. So this is the supply point, neutral, earth and line. So this is nothing but a clip. These clips are holding the PVC pipe. This PVC pipe holds the wire. Inside the wire is available, over which PVC pipe, and that is held by these clips. So the junction box, so these two are clip, another junction box, then clip, then we go to the lamp. Here another three clips are available. Here only elbow is available. In order to make the bend, elbow is available. This is another switch box. So in this we can control the lamp by using the switches. So it is a switch. So the L is refers line or phase, E refers the earth, N refers the neutral. So this type of wiring only now we are using. This PVC pipe, this clip, everything is buried inside the wall. It's not available, not visible. It is available inside. Only the switchboard are available at the outside. We can use this type of wiring over the wall also. If the new house is constructed, during the construction itself, all this PVC pipe, this clip, everything is placed inside. If already house is constructed, we want to go for some modification, then we can place all this outside. That is according to our requirement. So in this video we discuss about the 4 type of wiring. The 4th type is currently we are using. The remaining 3 types also used in the industries or domestic based on the application, based on our requirement. So subscribe this channel for more videos, and the link is available in the description box, and also course material drive link also available. Thank you. Welcome viewers. In this video we will see the abbreviations available in the electrical wiring. Subscribe this channel for more electrical videos. The soft copy of this course material available in the drive link. The link is given in the description box. Now we'll go to the abbreviation. The voltage is abbreviated by V. The ampere current is given as A. The low tension line means LT. Low tension line means 230 volt supply. The high tension line 11 kV, 110 kV, 33 kV, that is given by HT. So LT, HT. LT refers the low tension line, HT refers the high tension line. Then oil circuit breaker is given as OBC. Oil circuit breaker is given by OBC. Kilovolt means kV. Then MS, nothing but a main switch. SMS mean sub main switch. There is one main switch will be there, over which so many sub main switches are available. So MS refers the main switch for the entire supply. SMS refers sub main switch for a particular section. Then DB. DB is nothing but distribution box. Distribution box for a entire wiring, it is distributed through this box, that is given by DB. CB means control board. By controlling the various distribution, the box is available as a control board. Then SB means switchboard. the controlling the various apparatus. We have switchboard. Then DOL. DOL means direct on line. Is used in the motors. This motor can be directly connected. DOL switch. The motor is connected directly. At the time we are using this term DOL. Then ICDP. There is nothing but iron clad double pole. So one of the main switch. One of the main switch. It is made up of iron clad double pole. That's why it is called a ICDP. Then AAC, all aluminum conductor. We have aluminum conductor and copper conductor. If all are aluminum conductor, then it is given as AAC. Then ICTP, iron clad triple pole. Double pole having 2 wires. Triple pole means 3 wires. May be used for 3 phase. This may be used for single phase. Then DC, we know that DC means direct current. Then AC, AC means alternating current. We have the 2 major current, AC, DC. ACB means air circuit breaker. We already discussed oil circuit breaker. This is a air circuit breaker. CT refers current transformer. EHV means extra high voltage. Already high voltage available. Extra high voltage means more amount of voltage. Then EMF. EMF refers electromotive force. In electrical we are having EMF. Similarly for magnetic circuit we have MMF. This is EMF. Then FET means field effect transistor. HPMVL refers the high pressure helium vapor lamp. High pressure. Similarly low pressure also available. LP. This is HP. HPMVL vapor lamp. IC means integrated circuit. Then JFET. JFET refers junction field effect transistor. Then LVHV, low voltage, high voltage. It's mainly used in the transformer, low voltage side, high voltage side, primary winding and secondary winding. So we already discussed HT and LT, low tension and high tension supply. Then KVA, KVA refers kilovolt ampere. Kilovolt ampere is the apparent power. Then kilovolt, kV, voltage is the normal one, kilovolt in order to have the 10 to the power 3 is defined as kV. V into A, voltage and ampere. This is kilovoltage ampere, this is normal voltage and ampere. Then kilowatt hour, watt hour used in a energy meter, kilo kVh. Then lightning arrestor is LA, lightning arrestor LA. LDR refers light dependent resistor. Light dependent resistor means depends upon the lighting, the resistance value will vary. That's called LDR. LPMVL, low pressure helium vapor lamp. We already discussed the high pressure HPMVL. This one low pressure MVL, helium vapor lamp. Then LED is a light emitting diode, one special type of diode, light emitting diode. So then nowadays we are using the LEDs. For every lamp everywhere we are using LED. Then PT, potential transformer. We already discussed the CT, current transformer. So this one is the potential transformer. Then we'll go to the some more. If it is connected in series, is given as SE. S into SE, capital S, small e. If it is connected in shunt, is given as SH. Then SWG means standard wire gauge. Standard wire gauge is given as SWG. So while selecting the wire, what is the gauge? That is given by SWG. Depends upon the gauge, the current rating, voltage rating will be differ. So while going with any design, we need to see what is the wire gauge. Then SCR, silicon control rectifier, thyristor. Another name is thyristor. So it is given as SCR. UJT, one type of transistor, unijunction transistor. Then CRO, cathode ray oscilloscope. Then these three are very important parameters: resistor, inductor and capacitor. R given by resistor given by R, inductor given by L, capacitor given by C. So in this video we discuss about the abbreviation used in the electrical wiring. Subscribe this channel for more videos. This material available in the drive. The drive link is given in the description box. Thank you. Welcome viewers. In this video we will see the electrical wiring symbol. It will be very useful for while doing any type of wiring. Subscribe this channel for more electrical videos and notification. This material available in the drive. The link is given in the description box. Now we'll go to the symbol. The first one is a direct current. It is represented by a line because this direct current is the magnitude is always independent of the time. Always have the same magnitude. So it is given by the line. Then alternating current. It is a sine wave, like a sine wave 50 Hz. Normally we are using the 50 Hz AC supply. So that it is given 50 Hz. Then we have neutral. Neutral means it is represented by N. In case of DC we have positive polarity and negative polarity. So it is given by plus minus. Positive polarity is given by plus, negative polarity given by minus. In AC supply what we have, earth is available, earth point. So that is given by this symbol. Right? It is given. The terminals are represented by the circle. Any terminal, either lamp or fan, everything, it is represented by a circle. This overhead line is represented by circle over which one line is there. So this represents the overhead line. Then junction. If any one or two wires are crossed over, the junction is represented by the circle. It is fully shaded. Circle with fully shaded. Then underground cable. It is represented like this. It is like inverse of the ground, earth. The earthing point is almost it is reverse. Then single phase. Only one phase available means same as the AC, but here represented by 1. It means that only one phase is available out of 3 phase. It is 50 Hz. Then resistor. This resistor fixed is given within a box. R is available. It means fixed resistor. If this line is there, mean it is variable. We can vary the value of the resistor. This is fixed one. This will be variable one. Then impedance. It is represented within a box Z. Z is nothing but a impedance. The inductor is represented by L. Within a box L is given. Then fixed capacitor, variable capacitor. You know that this is symbol of the capacitor. If this R mark is available, mean it is a variable capacitor. The value can be varied. Then winding. The windings are represented like this. Is a coil. A number of coils. This symbol is symbol for winding. Then we have frequency meter. Is given within a circle Hertz because the unit of the frequency is Hertz. The plug point. One box is there, only one side it is represented by one line. On both the side line means that it is different. Only one line is there. Then fuse. So this is the wire available over which one box is there. That means the conductor is going through a fuse, or it can be represented like this. Two circles available, it is cross multiplied like that, so that there is a fuse. If any abnormal condition occurs, it will glow. So it is passing through this or passing through the circle. Then socket, either 5 ampere or 15 ampere, it is represented like this. It's a socket. Then fault. The fault is represented by these lines. It's like a thunder. Then buzzer is represented by semicircle below which the lines are available. Then wall mounted lamp. This cross mark. This side one line is there. Left hand side. It means that it is a wall. It is represented wall. Wall. Over the wall the lamp is available. Then ceiling mounted. Same cross mark. The top the line is there. It means this is a wall. This is the ceiling. The ceiling over which through that the lamp is available. So this line represents like a wall, this line represents like a ceiling. If it is general lamp outlet mean cross mark. Then ceiling fan, one small circle and one big circle is there, ceiling fan. Exhaust fan means same thing over which one circle is available. Then bracket fan means one line is available. The fan regulator, one box is there over which one small semicircle is available. Then bell. Bell is represented like this. So small, when a small circle below which the lines are available, over which the lines are available, buzzer. This is the bell. Then siren. It is the circle is available over which the 8 lines are available. Cross lines are available. The starter. It is used in the motors. See, there is some disconnection is there. The semicircle is there one side, this side. So this connection is there. So when it is contacted, it will start. The motor will start. The supply will be given. Then isolator. This is the supply line. There is a isolation is there. Then circuit breaker. One box and 2 lines are available in the vertical manner, not a horizontal manner, vertical manner. So it will. So the line is going through the breaker. Then we have ammeter, voltmeter, multimeter and wattmeter. Ammeter represented by A. Voltmeter represented by V, voltage. Multimeter means we can measure voltage, current and resistor. So that is given VAR. Then wattmeter represented by W. Watts is the unit. So represented by W. Then ohm meter. This is symbol for ohm, resistance. Then power factor meter means cos pi. So that it is circle over which cos pi is given. Then AC motor or DC motor. Circle M is available. DC motor mean line, DC current. AC motor mean sine wave. So this M represents motor. This sinusoidal wave represents AC. This straight line represents DC. Similarly, DC generator and AC generator. So it is represented by G. G means generator. Here also straight line means DC, sinusoidal wave means AC. Then the wiring. We will go to the wiring types. Concealed wirings. The line is available over which the terminals are available. General wiring means just one line. Wall surface wiring. See this is going upward, this is going downward. The wires are going downward, so that wall surface. Surface contact wiring. Same thing, one circle is available. Surface contact wiring, the same process, same diagram with one circle is available. Concealed contact wiring. This wire, circle, everything available upward direction. Main fuse board without switches. Only main fuse board. The switches are not available. So one rectangle fully shaded. Then main fuse board with switches. It is halfly shaded. Previously fully shaded, and now it is half of the portion is shaded. That indicates the switches are available. Then distribution fuse board with the switches. So the half of the portion is lines are available, cross lines. Previously shaded. Without switch mean fully the cross lines are available. Then changeover contact. So this is the main supply. You can change from one point to another point. Either we can connect this side or this side. That's why it's called a changeover switch. Then the time switch. So based on the time it will close. So that the time also available, the contact also available. Then wire crossing. This symbol indicates there is no connection between these two wires. This is run over which. This is one line, this is another line. It is run over which there is no contact. Then main fuse board without the switches. So fully shaded. But two boxes are available. If it is one box is available, previous case, distribution box. So with the switches are available mean two boxes available in the partly shaded. If it is fully shaded without switch, partly shaded, with the switch. Then distribution fuse board for power with switches, without switches, so fully shaded. So 2 boxes with the lines, dashed lines. If the switches are available, mean partly shaded, half of the portion shaded. Then we have neutral link. Neutral link means like this. So there is a neutral available here. Then contact normally open means it is in open condition. Closed means it is closed condition. It indicates these two are closed. These are open. Normally open means normal condition it is open. Abnormal condition it will close. Then two-way switch. Two-way contact with normal condition. So either it will two-way means either it will connect this end or this end. Then single pole, single throw. Only one pole is available, only one thrown. Mean like this. Suppose single pole double thrown. Only one switch thrown on either side is indicated by this. This side or this side, that side. So in this video we discuss about the symbol used in the electrical wiring. The course material link available in the description box. You can view the course material. Subscribe the channel for more videos and notification. Thank you. Welcome viewers. In this video we will see the electrical wiring layout 1. The first one is the one lamp controlled by one switch. Very simple circuit, very basic circuit. Subscribe this channel for more electrical videos related to the electrical wiring and other topics. The material for this topic available in the drive. Drive link is given in the description box. Now we'll go to the topic. So we need to control one lamp by using one switch. So this is the lamp available. This is the switch is available. So we have the 230 volt 50 Hz AC supply is available. We know that the two terminals, phase and neutral. Neutral always directly connected to the lamp. The neutral link NL, by using NL, neutral is directly connected to the lamp. The phase is always connected to the lamp through the fuse as well as the switch. Neutral is directly connected. Normally the neutral is directly connected. Phase is connected through fuse and switches. The fuse used to protect the circuit from the rated current. If the circuit drawn more than rated current, this fuse will glow and this entire circuit is protected from the overloading. The switch is used to control the lamp. When the switch is on, the supply is given to the lamp will glow. When the switch is off condition, supply is disconnected, the lamp in off condition. So the one main requirement is neutral is connected directly, phase is connected through the fuse and switch. By controlling the switch, we can control the glow of the lamp. We can on and off the lamp by using the switch. We need to follow the standard colors for phase wire. We need to use the red color wire. For neutral, we need to use the black color wire. For earth, we need to use the green color wire. Here earth is not shown, but entire wiring we need to run the earth wire also. Further, we need to use the green color. Now by this distance, we can able to decide how much PVC pipe and how much copper wire is required. Length of the PVC pipe and length of the wire can be decided. So this is 15 centimeter. The distance between this supply and switch. And this distance is 20 centimeter and this one another 20 centimeter. So totally 40 centimeters. So 40 plus 15, 55 centimeters. So we need 55 centimeter of PVC pipe. So that we can design according to the distance, we can decide what are the materials required also. Now we'll see some procedure. What are the procedure need to follow while doing the wiring. The phase wire always connect in fuse and switches only. We already discussed. Neutral is connected directly. The phase is always connected through the fuse and switches. the phase should not connect it directly. Always it should connect through the fuse and switch. Then only we can control, and also we can go for the protection. By using the fuse we can protection. And also when the switch is off condition, the supply is not given to the apparatus. Otherwise the supply is always available if it is connected directly. And another important thing, protect the circuit with rated fuse. Fuse rating is very important. If the bulb is taking 2 ampere means we need to use 2 ampere fuse, not less than and not more than, right? We need to use the exact rating of fuse should be used so that we can protect the circuit. We should not use lesser amount or higher amount of higher amperes. We need to use the exact amount. Insulation of wire and end of the conductors are very close to the terminal. So while removing the insulation, we need to remove what are the things needed, that portion only we need to remove. The insulation should not removed for more portion. Only less amount of insulation should be removed and it is connected to the terminal. The insulation should be nearer, very close to the terminal, so that we can avoid the shocking. Avoid over tight and breakage of accessories while making the connection. So the tight, while giving the tight, it should be exactly the same amount of tightness will be given, not over tight or not loosely tightened. And so that we can avoid the breaking of accessories while making the connection. So these things we need to follow while doing the wiring. First is phase is connected through fuse and switches. Rated fuse should be used. Insulation and the terminal should be very closer. And over tight, we need to avoid over tight and breakage of accessories while making the connection. Now we'll see what are the requirements are needed, what are the things needed while doing this wiring. There's one switch, one bulb is controlled by one switch. So the PVC contact pipe, we already discussed this 20 millimeter, the thickness 20 millimeter, diameter 20 millimeter PVC pipe is required 55 centimeter. We already decided 20 centimeter plus 15, it is 55 centimeters required. The diameter of the pipe is 20 millimeter because we are going to run only one bulb and one switch. So the 20 mm pipe is enough. The neutral link is 60 ampere 240 voltage, one number is required. The rated voltage is 240 and the current requirement is 16 ampere. Then fuse unit 16 ampere 240 voltage, one number is required. Then PVC box. So we have only one switch, so that 4 cross 4, one number is enough. 4 into 4, 4 inch, 4 inch to 4 inch PVC box, one number is enough. Then PVC junction box, three-way junction box is needed. That is one way, one side supply, one side lamp, another side switch box. So that we need three-way junction box is needed. Right, one is used for supply, another one is used for switch, another one is used for lamp. That one number is required. 20 mm. Already we have 20 mm PVC pipe, so that junction box also 20 mm. Both should be same. Then steady batten holder, 5 ampere 230 volt, one number. Bulb holder, one number is required. PVC insulated copper wire. The copper wire is 1 square millimeter is enough because only one lamp we are using. 150 centimeter is required. Starting from subplate to the lamp wiring, everything, it is 150 centimeter. Then SPST switch, that is the switch, normal switch, 6 ampere 230 volt, one number. What is SPST? Single pole, single throw, that is on and off, only one pole. Single pole means only we are controlling the phase, only one connection. Single thrown means either on or off. Double pole, double thrown also available. Here we need only single thrown. Metal saddle, 20 millimeter, 3 numbers are required. Then screw size. In order to tightening, the screw size is required. The 30 into 4 millimeter, 4 numbers required. 25 into 6 millimeter, 12 numbers required. 38 and 6 millimeter, one number required. So all this rating based on the incandescent lamp. We are using 60 watts 230 volt. one number. So based on the 60 volt, the other requirement may be vary. So we decided to put the incandescent lamp of 60 watts to 30 volt. Accordingly, the above requirements are needed. So in this video, we discuss how to go for a wiring with one lamp controlled by one switch. Subscribe this channel for more electrical layout and other topics. The link is available in the description box. Thank you. Welcome viewers. In this video, we'll see the electrical wiring layout. Second topic, two lamps controlled by the one switch. The lamp is connected as series. Only one switch controlled by two lamps connected in series. Subscribe this channel for more electrical videos related to the wiring and other topics. The material for this topic available in the drive link. The link is given in the description box. Now we'll go to the topic. So we need to control the two lamp. We have two lamp available, lamp 1 and lamp 2. So it is controlled by only one switch. These lamps are connected in series. We can connect in parallel also. But in this topic it is connected in series. So lamp 1, lamp 2 controlled by one switch. So this is a supply terminal, supply end. So normally this neutral is connected directly to the lamp. Neutral end is connected directly. The supply we have phase and neutral. Neutral is connected through the lamp, directly connected through the neutral link. This is called a neutral link. The phase is always connected through fuse and switches. The phase should not connected directly. It should get connected through phase and switch. Fuse and switches. The fuse is used to protect the circuit. If any overcurrent taken by the circuit, the fuse will glow. Then the supply is disconnected to the circuit. So the entire circuit will be protected. So the fuse will protect the circuit if any overcurrent is taken by the circuit by glowing. So it will cut out the entire circuit. The switch is used to control the glow of lamp on and off. We can turn on, turn off the lamp by using the switches. So that the phase should be connected to fuse and switch. Fuse used to protect the circuit, switch used to control the lamp. Right? So the now neutral is connected directly. On other end, phase connected through fuse and switch. So if the switch is closed, what will happen? The supply is given to this lamp, lamp 2. Then lamp 2 is connected in series with the lamp 1. So that supply will given to lamp 1 also. Already here neutral is available. So here phase is available. So both the lamps are connected in series. So both the lamp will glow. But the voltage will be divided here. The current will be same. Because of series circuit, current will be same. This 230 voltage is shared by lamp 1 and lamp 2. So that the brightness will reduce. Because we are connected in series. Series circuit means the current will be same, the same amount of current. But the voltage will be divided. So that the brightness will reduce. So by controlling the switch, we can control the glow of lamp 1 and lamp 2. Both are connected in series. So in the wiring, we need to follow the standard colors. The phase wire, we need to use the red color. Neutral wire, black color. Earth wire, green color. Here earth wire is not available, but the entire wiring we need to follow. We need to run the earth wire also. Here it is not shown. Right? So incandescent lamp, what we are using 60 watts to 30 volt. So that we can decide the other ratings. Fuse rating, either current rating, everything will be decided from the rating of the lamp. So that is important. We decided 60 watts to 30 volt. Now we can decide the PVC pipe requirement as well as wire requirement by seeing this, the distance. So this is the 10 centimeter here. Here this distance is 20 centimeter. This distance is 30 centimeter. This distance also 20 centimeter. So by adding all, we can decide how much of PVC pipe is required. So it is nearly 100 centimeter of PVC pipe is required. This 20, this 20, 40, this 30, 70, then 80, this 20, 100. So 20 plus 20 plus 20, 60. This one 70, 70 plus 30, 100 centimeter is required. So in this diagram, the important thing is two lamps are connected in series. So the current is equal, the voltage is shared by the two lamps. So the brightness will reduce. Another important thing, neutral is connected directly, phase is connected through phase and the fuse and the switches. Now we will see what are the things we need to follow while doing the wiring. The phase wire always connect in fuse and switches only. We already discussed. Phase wire always connected through fuse and switches. And protect the circuit with rated fuse. Rated fuse means exactly what amount of current taken, that amount we need to use. We should not use more rating or lesser rating. The insulation of wire and end of the conductors are very close to the terminal. We should not remove the insulation much more. Required amount of insulation only should be removed and it is connected to the conductor, so that there is no open terminal, so that we can avoid the shocking. Avoid over tight and breakage of accessories while making the connection. We should not go for over tight and should not breakage the accessories. Now we will see what are the requirements needed for this wiring. Two lamp controlled by the one switch. Then incandescent lamp what we are using is 60 watts 230 voltage. Based on that we can see what are the requirements needed. So the PVC contact pipe needed 100 centimeter. We already discussed. Based on the layout, based on the distance, it is 100 centimeter. 20 millimeter diameter is enough, because we are using only one set of wire. Only two lamp with only one set of wires. The neutral link what we need is 16 ampere 230 voltage 1 number neutral link. The fuse unit what we need is 60 ampere 230 voltage 1 number. Then PVC box 4 into 4 inch 1 number is required. Then PVC junction box 3-way, that is 20 millimeter dia, 20 millimeter. See, this is also 20, this one also 20. PVC pipe 20 millimeter, so that box also 20 millimeter junction box 1 number. The one side we are using supply, second side we are using the switch, third side we are using the bulb, so that we need 3-way. Then steady batten holder 5 ampere 230 volt 1 number. Then PVC insulated copper wire 1 square millimeter is enough, because we are using only 2 bulb, 290 centimeter is required. Then SPDT switch 6 ampere 230 volt 1 number. Single pole, single throne. Only single pole, only phase is controlled. Single throne means on or off. Then metal saddle 20 millimeter, we need 6 numbers. Then screw, steel screw what we need is 30 into 4 millimeter 4 numbers. 25 into 6 millimeter 80 numbers. 38 into 6 millimeter 2 numbers. So these are all the required materials for doing this wiring. 2 bulb connected in series controlled by the one single switch. So subscribe this channel for more videos and notification. The link is available in the description box. Thank you. Welcome viewers. In this video we will see the electrical wiring layout third model, third type. That is 2 lamp controlled by the 2 switches parallel. There are 2 lamp available controlled by 2 different switches independent connected in parallel. Subscribe this channel for more electrical videos related to the wiring and other topics. The material available in the drive, the link is given in the description box. Now we'll go to the topic. Now consider the 2 lamps are available here. So lamp 1 and lamp 2 is connected in parallel. The series is connected in series topic, that is available in the previous topic. 2 lamp connected in series, but in this topic 2 lamps are connected in parallel. Parallel means the voltage will be same. The same amount of voltage is given to lamp 1 as well as lamp 2. But if it is connected in series means the voltage will be different. So we have lamp 1, lamp 2. There are 2 switches, switch 1 and switch 2. Lamp 1 is controlled by switch S1. lamp 2 is controlled by switch S2. So this is the supply end, 230 voltage, 50 Hz AC supply is available. So we have two terminal, phase and neutral. So the neutral is always connected directly. Only phase is controlled through the switch. So neutral is connected through neutral link to the lamp directly. So this neutral is connected. From neutral, one more tapping is taken, that is given to the next lamp. So that neutral is connected to lamp 1 as well as lamp 2 directly. So this is called a tapping. We need to take one tapping, then that wire is connected to lamp 2. Now the phase is connected through the fuse. The fuse used for protecting the circuit. If any over current taken by the circuit, the fuse will glow. Glow means it will cut the entire circuit, so that the circuit is disconnected from the phase. Then it is given to the switch, one terminal switch is there. So if you turn on the switch, this connection will be made. Now it is in off condition. If you turn on the switch means the connection will be this is connected. If it is connected, the phase will be given to another end of the lamp. Already neutral available. Now when it is turned on the switch, this contact will be made. Due to the contact, the phase will apply to the lamp, so the lamp will glow. If the switch is turned off, in off condition means this connection will be disconnected. This terminal will be disconnected, the lamp will be in off condition. So independently by turn on, turn off, we can control the glow of this lamp. Now phase is available here, one tapping is taken, that is given to the next switch S2, one terminal of the switch S2. So this is called a tapping. The phase available through the fuse, it is connected to one end of the switch. In order to connect the next switch, one tapping is taken, that is run, the wire is run and given to the next switch. So by closing the switch, this contact will be made and phase is given to the second lamp. So the lamp will glow. If it is disconnected, the lamp will be in off condition. So the lamp 2 is controlled by the switch S2. So we can control lamp 1 and lamp 2 independently by using the switch S1 and S2. Right? So the neutral is connected directly to the lamp, phase is connected through the fuse, switch S1 as well as S2. During the wiring, we need to follow the standard colors of the wire. The phase wire, we need to use the red color wire. Neutral, we need to use the black color wire. For earth, we need to use the green color wire. The earth is not shown here, but entire electrical layout we need to run the earth wire also, but it is not shown here. Then incandescent lamp, what we are using, 60 watts, 230 voltage. So based on that only we can decide the wire size, everything, so that lamp rating is very important. Now by seeing the distance, we can decide the how much length of PVC pipe is required, how much length of wire is required. So this is 10 centimeter, this is 30 centimeter, this is 20 centimeter. So that this is also 20 centimeter. This will be another 20 centimeter. So the 20 plus 20 40, here on 40 80, this one 90 plus 30, 120 centimeter of PVC pipe is required. 20 plus 20 40, 40 plus 20 60, 60 plus 20 80, 80 plus 10 90, 90 plus 30, 120 centimeter of PVC pipe is required. Now we'll go to the what are the precautions we need to follow. What are the steps we need to follow during the connection? The phase wire always connect in fuse and switches only. Only neutral is connected directly. The phase wire always it should connected through the fuse and switches. Protect the circuit with rated fuse. Rated amount of fuse should be used, not much more or not lesser. Insulation of wire and end of the conductors are very close to the terminals. While removing the insulation, we need to remove the required amount. We should not use more insulations, so that it is very close to the terminal, so that we can avoid the open terminal and we can avoid the shocking. avoid over tight and breakage of accessories while making the connection. Should not go for any over tight. What amount of tightness required, that only we need to apply, so that we can avoid the breakage of the accessories during the connection. Now we'll see what are the equipments needed, what are the materials needed for the connection of this two lamp controlled by the two different independent switches. So the PVC contact pipe we already calculated, it is required 120 centimeter. Is 20 mm diameter is enough, because we are running only one set of wire, only two lamps we are controlling. So 120 centimeter of 20 mm diameter is required. The neutral link is 60 ampere 230 voltage, one number is required in order to connect the neutral. The fuse unit is 60 ampere 230 voltage, that is one number. PVC box 4 into 4, one number. Then PVC insulated copper wire 1 square millimeter 360 centimeter. So that can be calculated from the requirement. PVC junction box 3-way 20 millimeter. So the PVC pipe is 20 millimeter. So the junction box also 20 millimeter. That is one number. Then steady batten holder, lamp holder 5 ampere 230 volt. That is also one number. SPDT SPST switch 6 ampere 230 voltage, one number. SPDT means single pole single throne switch is required. Metal saddle 20 millimeter, 6 numbers are required, and these screws are required. 13 into 4 8 number, 26 into 6 20 number, 38 into 6 2 numbers. So this is the requirement. So in this video we discuss about the two lamp controlled by two different switches independently connected in parallel. Subscribe this channel for more videos. The link is available in the description box. Thank you. Welcome viewers. In this video we will see the electrical wiring layout, fourth model, one lamp, one calling bell and one socket, plug point. Subscribe this channel for more electrical videos related to the wiring and other topic. This material also available in the drive link. The link is given in the description box. Now we'll go to the topic. So we have one lamp, one calling bell and one plug point. Now refer the diagram. So the one lamp is available. This is a calling bell. This is a plug point. So we need to go for the wiring of these three accessories: lamp, calling bell and the plug point. So here the 230 volt supply available, 230 volt 50 Hz AC supply available. So the neutral is always connected directly to the accessories, directly to the lamp through the neutral link. So the neutral is directly connected to this lamp. From lamp one more tapping is taken, that is connected to the calling bell. From calling bell one more tapping is taken, that is connected to the neutral of the plug point socket. So the now neutral is connected through neutral link directly to the lamp, to the calling bell and then neutral point of a plug point. The phase is connected, always connected through the fuse and switches. The fuse is used to protect the circuit. Based on the rating, if you put the fuse, if any abnormal condition or over current, the fuse will glow. Fuse will glow means the circuit will be disconnected, so that we can protect the circuit from the over current. So phase always connected through the fuse. Then it is given to the switches. Switch S1. Switch S1 used to control the lamp 1. So when the switch is closed, the supply, the new phase is given to the lamp, so the lamp will glow. From this point the phase is taken, tapping is taken, that phase is connected to the switch S2. This switch is used to control the calling bell. It's a push type. When it is pressed, it is turned on. When it is released, it will be turned off. but this switch is, when it is turned on, it will be in on condition always. This is a push type. So when it is closed, the calling bell will ring, the ringing of calling bell. So from here one more tapping is taken, that is given to the face of the jacket plug point. So when you put the plug point here, we will get the phase and neutral supply. Here also one switch will be available. So the neutral is directly connected, phase is connected through fuse to the switch S1 to control the lamp. Then tapping is taken, gets given to the switch S2, this is a push type switch, control the calling bell. From here again one more tapping is taken, that is given to the 3-pin plug, so that we can control the plug point also. The earth line is run through the entire wiring network and on the plug point also, earthing point, so that this is become a 3-pin plug. Now based on the distance, we can calculate the PVC pipe and wire requirement. This is 15 centimeter, this is another 15 centimeter, this is 15 centimeter, this will be 20 centimeter, so that this also 20 centimeter. This entire length is 20 centimeter. So by adding all, we can decide how much length of PVC pipe is required. Then we will see the incandescent lamp rating. This is 60 watts 230 volt supply. The lamp what we are using is 60 watt 230 volt. So based on the rating only we can decide the fuse and other ratings, so that we need to decide what type of lamp and what is the rating of the lamp we are going to use. Now we will see some procedure. What are the procedure we need to follow during the entire wiring process. So we need to follow the standard color. For phase we need to use the red color cable. For neutral we need to use black color cable or wire. For earth connection we need to use green color cable or wire. We need to follow these standards. We already discussed the phase wire always connect in fuse and switches only. The phase is connected through the fuse and switches. Neutral is connected directly. Protect the circuit with rated fuses. We need to put the rated fuse so that we can protect the circuit. The rating should not more than or should not less than. It should be exactly what we need. Insulation of wire and end of the conductor are very close to the terminals. We should not remove more insulation. Whatever required we need to remove that insulation only, then it is connected very close to the terminal, so that we can avoid the open terminal as well as we can avoid the shocking, and also avoid the over tight and breakage of accessories while making the connection. We should not go for any over tight, we should need to avoid the breakings. Now we will see what are the equipments needed to go for this wiring. One lamp, one calling bell and one plug point. So first we need a PVC contact pipe 20 millimeter diameter, because we have only 3 equipments: lamp, calling bell and plug point. So this 20 mm is enough. 145 centimeters is required. Based on the diagram, the dimensions given, based on that we can decide it is 145 centimeters is required. PVC junction box 4-way, because we need 4-way available. One is going to lamp, another one going to lamp, then plug point, then switches. So that 4-way junction box is needed, 2 numbers. The neutral link is 6 ampere, 16 ampere, 240 voltage. 1 number is required. Fuse unit 16 ampere, 240 voltage. 1 number is required. Then PVC box 4 x 4 inch, 2 numbers required, and 6 x 4, 1 number is required based on the requirement. Then other requirements are PVC insulated copper wire 1 square millimeter is enough, because we need only 1 lamp, 1 plug point and 1 calling bell. That is 480 centimeters required. Based on the diagram, the dimensions given, from that we can decide. Steady baton holder 2 numbers, in order to keep lamp and the calling bell, 2 numbers required. SPST switch 6 ampere 230 voltage, 3 numbers, one for lamp, one for calling bell, one for plug point. Metal saddle 20 millimeter, 8 numbers required in order to fix the PVC cables. Then steel screw 13 into 4 millimeter, 12 numbers required, 25 into 6 millimeter, 34 numbers required, 38 into 6 millimeter, 2 numbers required. Then PVC bend 20 millimeter, 1 number required. 2 in 1 socket 6 ampere 230 volt, 1 number required. Then VIR wire 1 bar 18 gauge 80 centimeter required. So these are all the requirement to complete this electrical wiring, this model. Subscribe this channel for more videos and notification. The material link available in the description box. Thank you. Welcome viewers. In this video we will see the electrical wiring layout, 5th model, staircase wiring. One lamp is controlled by 2 different switches kept in the 2 different places. Normally in the staircase, the ground floor to first floor or first floor to second floor, like that we can control. The lamp is controlled independent of 2 switches. The switch 1 they are able to turn on, turn off the lamp. Switch 2 also turn on, turn off the lamp. So that is called a staircase wiring. Now we'll go to the diagram. So this is the lamp we need to control. Only one lamp available in the staircase, that should be controlled by these 2 switches. Either switch 1 or switch 2. We can able to control the lamp with the switch S1 alone or switch S2 alone or both combinations. If you operate any one switch, if the lamp is on off condition mean it will turn on. If it is on condition mean it will be turned off. So that is the main objective of this wiring. So we have 230 volt 50 Hz AC supply available. The 2 terminals, phase and neutral, is available. Normally the neutral is directly connected to the lamp. Neutral wire is always connected through the neutral link. It is directly connected to the lamp. The phase end is connected through the fuse and switches. The phase is connected through fuse and switches. The fuse is used to protect the circuit from the overcurrent. If any overcurrent occurs in the circuit, the fuse will glow, so that the supply is disconnected. The entire circuit is disconnected from the supply, so that we can avoid the overcurrent damaging of the circuit. That is the purpose of fuse, so that phase is always connected to the fuse. These switches are used to control the lamp. So the phase is connected through fuse and switches. Now we'll see the connection. So that 3 terminals available in switch S1 and S2. The terminal 1, 2 and 3. Similarly 1, 2 and 3. So this is the normally on position. If it is in upward direction, normally on. Here it is in on condition. If it is kept here, it is off condition. Downward is the off condition. Upward is the on condition. Now both are in on condition. How it is connected? The neutral is connected to one end of the lamp. Other end of the lamp is connected to terminal 3. Terminal 3 of the switch S2. So this is one circuit. One wire is the neutral wire connected to the lamp. Other end of the lamp connected to third terminal of the switch S2. This third terminal of S1 and first terminal of S2 are short circuited. Both are short circuited. Similarly, second terminal of switch S1 and second terminal of switch S2, that also short circuited. This terminal 1 is energized by the phase, connected to the phase. Right? So the terminal 1 is connected by the phase. Terminal 2 short circuited. Terminal 3 and terminal 1 also short circuited. This terminal 3 connected to the lamp. So this is the connection. So we need to run one wire connecting the phase to the lamp to the terminal 3 of S2. Another wire connecting terminal 3 of switch S1 to terminal 1 of switch S2. Another wire connecting the terminal 2 of S1 as well as S2. another wire connecting phase to the terminal 1 of S1. Right? So there are 4 wires we need to run: neutral, this wire, and this central wire, and this phase wire. The upward direction is the on condition, downward mean off condition. Now both are in on condition. Now we'll see there are 4 possible options available. S1 and S2 are in on condition. What will happen? Neutral is already connected. The phase will connected through S1. So it is in on condition. So it will go like this. This is also on condition. So it will, the supply is given to the lamp. Right? If both are on condition means from phase to passing through the fuse and switch S1 and this center wire, then switch S2, and it will go to the lamp. Now the lamp will glow. If you operate any one switch, if you change the any one switch, the lamp should be in off condition. Now we are turn off the switch S1. That is the switch is now brought to the downward. This disconnected. This end is disconnected. This terminal is connected. Now what will happen if this terminal is connected? The phase is going through the fuse and it will go to the off condition, this condition, not in the upward, the terminal 3. But here the terminal 3 is in open condition. Here there is no connection. So the lamp will be in off. So in the second condition, the first condition both are in on condition, the lamp will glow. If you switch off the switch S1, the lamp will be in off condition because it is disconnected. There is no connection here. Now connection available like this in the off condition. If S2 is also in off condition, that is this terminal is brought down, what will happen? The phase going through the fuse is already in off condition. It will go here. So this also in off condition. Now it will go to the lamp. The supply is given to the lamp. The first condition is given through the on. Now it is going through the off condition. Both are in off condition mean the circuit will close like this. In this condition, if you turn on this switch S1 again, what will happen? This will be disconnected. The supply will go here, but this is in open condition, so the circuit will not close. So the bulb will be in off condition. Right? So initially both are on, the lamp is on. The switch S1 is put into off, so the lamp will be turned off. If S2 is on, if S2 is also kept in off, the switch will be on. If S1 is on and S2 is off, that also the lamp will be in off condition. So it is operated independently. So if any one switch is operated, if the lamp is in on condition, it will off. If it is off condition, it will on. See here, both are on mean off. Both are on, the lamp also on. This while operating the switch S1, it going from on to off. While operating the switch, it will go from off to on. While operating the switch, it will go from on to off. They keep on changes. Any changes in the position, the lamp condition also changes. We need to follow the standard colors for the wire. For phase wire, we need to use the red color. For neutral wire, we need to use the black color. For earth wire, we need to use the green color wire. Now we'll see what are the procedure we need to follow while doing this staircase wiring. The phase wire always connect in fuse and switches only. The neutral can be connected directly, but phase wire always we need to connect with the fuse and switches. In order to go for a protection, using fuse we can protection, switches we can control the lamp. Protect the circuit with the rated fuses. The rating of fuse is very important. Based on the accessories we need to choose. We should not choose greater or lesser value. Exact value should be chosen. Insulation of wire and end of conductors are very close to the terminals. We should not remove the insulation much more. The required amount of insulation must be removed and it is connected to the terminal, so that we can avoid open circuit and also we can avoid the shocking. Avoid over tight and breakage of accessories while making the connection. We should not go for over tight and should not break the accessories. Now we will see what are the equipments needed, what are the materials needed to complete this staircase wiring. So PVC contact pipe of 20 millimeter diameter is required 105 centimeter. The distances are given in the diagram. Based on that we can calculate 105 centimeter. That is depends upon our requirement. The incandescent lamp what we are using 60 watts 230 volt one number. So based on this rating only we can decide the other ratings. The PVC junction box 3-way we need one number 20 millimeter diameter. Neutral link 16 ampere 240 voltage one number required. Fuse link 60 ampere 240 voltage one number is required. PVC box 4 into 4 inch 2 numbers required. Insulated copper wire 1 square millimeter is enough because we are using only one lamp, that is 280 centimeter is required. Then steady batten holder 5 ampere 230 voltage one number in order to hold the lamp. SPDT switch 6 ampere 230 volt 2 numbers required. Single pole double thrown. Single pole means only phase is connected, double thrown means there are on and off. Three terminals available, so that there are double thrown. We can go with on or off. Metal saddle 20 millimeter 6 numbers required. Steel screw 13 into 4 millimeter 8 numbers required. 19 into 6 millimeter 20 numbers required. 38 into 6 millimeter 1 number required. So these are all the requirements. So in this video we discuss about the staircase wiring, controlling the one lamp with two different switches kept in the two different places, normally in the staircase, first floor, second floor, like that. Subscribe this channel for more videos related to wiring and other topics. The material link also available in the description box. Thank you. Welcome viewers. In this video we will see the electrical wiring layout 6th model, godown wiring. So the godown is a big place. In that we can have 3 different lamps are available. Let us consider this is available at the beginning, at the entrance. It is available at the middle. It is available at the end. So we need to operate any one lamp is enough. While entering we need to operate, we need to turn on this lamp 1. While enter into the godown at the center place, we can turn on this lamp 2. At the end we can turn on this lamp 3. So any one lamp is required. So in this wiring we are able to operate these 3 lamps independently. We can operate this by using the switches. We can operate these 3 lamps according to our requirement. So subscribe this channel for more electrical videos related to wiring and other topic. This material also available in the drive link. The link is given in the description box. Now we'll go to the wiring. Now refer the diagram. So the 3 lamps available, lamp 1, lamp 2 and lamp 3. 3 different lamps are available. It is controlled by the 3 different switches. S1, S2, S3. 3 different switches are available. So here the supply is available. Supply is given. 230 volt 50 Hz AC supply is available. This is a phase neutral. 2 terminals are available, phase and neutral. So the neutral always it is connected directly to the lamp. So the neutral, through the neutral link it is connected to the lamp 1. From there one tapping is taken, that is connected to lamp 2, one end of the lamp 2. From there one tapping is taken, that is connected to one end of the lamp 3. So this neutral is connected directly to lamp 1, lamp 2, lamp 3, one end of lamp 1, lamp 2 and lamp 3. So the other terminal is controlled by the phase, controlled by the switches. So this phase always connected through the fuse and switches, because fuse is used to protect the circuit. In any overcurrent occurs, this fuse will glow, so the circuit will be disconnected from the supply. We can avoid any damaging. So it is connected through the fuse. Then connected through the switches in order to control the glow of the lamp. Lamp 1, 2 and 3. There are 3 switches are available. Now we'll see what is the connection available here. So this switch is the switch S1 is ST, single pole single thrown. only one pole is available, either on or off. If it is closed, on. If it is open, if it is on off condition. But switch S2 and S3 is the single pole double thrown. Double thrown means here if you put here on condition, if you put here off condition. The double thrown, double thrones are available. Here only one. If it is open off condition, if it is closed on condition. But here if you put here on condition, if you put here off condition. There are two poles are available. Here only one pole is available. Now we will see how to control the lamp. So our aim is while entering the godown, we need to operate this lamp 1. While going inside, we need to operate L2. While going at the end of the godown, we need to operate only L3. That is our aim. So while entering this one, lamp 1, while going to the middle, lamp 2, while going to the end, we need to operate L3. Right? L1, L2, L3. Now we will see how it is operated by using the switch. So the phase is connected to one end of this terminal. Then it is connected like this. It is connected to another terminal. This on is connected to lamp 1. This off condition is connected to next switch. Again this on condition is connected to lamp 2. This off condition is connected to lamp 3. Now we will see how the circuit is closed, how the supply is given to the different lamp. The switch S1 is the main switch. If you turn on S1, then only we can operate the entire operation. If S1 is in off condition, these two switches will not work out. We cannot operate the switches, right? So the S1 is in on condition, we can go to control S2 and S3. If S1 is in off condition, the entire circuit is disconnected. So we cannot go anything, right? So first we will consider this S1 is on condition. S1 is in the on condition. We will consider that S2 also on and S3 also in on condition. Like this, all are in the on condition. So what will happen if S1 is on condition, supply is given, this circuit is closed on condition. So it will go to the switch S2. What will happen here? It is in on condition. So the supply will go to the lamp 1. So the lamp 1 will glow. When S1 is on condition, S2 also on condition, S3 also on condition. S1 on condition means supply will close here. It will go to the switch S2. Here S2 is connected to lamp 1. So the lamp 1 will glow. Now what we are doing? We are turn off this switch S2. This switch S2 is off. So circuit is now closed here. This supply is disconnected. The supply is given to switch S3. Where S3 is connected to the second lamp. So now the second lamp will glow. First lamp will be disconnected because this end is connected here. It is turned off. Circuit will, the second lamp will glow. If the third switch also in off condition. So what will happen? Already this is in on condition. This is in off condition. So the supply will come here. Here also off condition. The supply will go to the third lamp. So the third lamp will glow. So what we need to do while entering the godown, we need to turn on this switch S1. So automatically lamp 1 will glow. Then while entering into the center place, we need to turn off this second switch so that lamp 1 will be off condition, lamp 2 will be on condition. While entering into that the end, this will be in off condition. We need to put this in off condition. So the lamp 3 will glow, right? So that we can operate this lamp 1 initially, lamp 2 middle, lamp 2 at the end. Suppose if the switch S1 is in off condition, we cannot do anything. So the supply is disconnected. This S2, S3 cannot be operated. All the lamps are in off condition. Now we'll see the tabular column so that you are able to understand easily. One tabular column is available. See this on condition. First 3, S1 is on condition so that we can operate the lamp. If S1 is off condition, while making the switch S2 or S2 either on or off, on and off, all the lamp will be in off condition, right? If S1 is off, all the lamp will be in off condition only. See the upward direction for on, downward direction for off. Suppose if S1 is on, first three condition S1 is kept in on condition. S2, S3 also in on condition. So lamp 1 is glowing. If S2 is put in off condition, lamp 2 will glow. If S3 is put in off condition, lamp 3 will glow. So we can operate this. This is lamp 1, lamp 2, lamp 3. By operating, S1 is on, S2 is off, S3 is off. So that we can operate like this. According to our requirement, we can operate. So we need to follow the standard color. For phase, we need to use the red color cable. For neutral, we need to use the black color cable. For earth, we need to use the green color cable. The incandescent lamp what we are using 60 watts 230 volt supply rating. So if you decide the rating, then only we can go for other requirements. Now we need to see the what are the procedure we need to follow. The phase wire always connect in fuse and switches only. That is neutral is connected directly. Phase wire always connected through the fuse and switches in order to protect the circuit and also control the circuit. Protect the circuit with rated fuses. Based on this rating, we need to decide the rating of the fuse. The rating should not more or should not less. We will see some more precautions. Insulation of wire and end of the conductors are very close to the terminals. So we should not remove more insulation. It should be, we need to remove what are the requirement, that amount of insulation should be removed, and there should be a closeness between the wire and terminal so that we can avoid open circuiting and avoid the shocking. Avoid over tight and breakage of accessories while making the connection. We should not go for any over tight. Now we will see what are the requirement of the wiring for this go down wiring. The PVC contact pipe we need 20 millimeter. 20 millimeter size we need 165 centimeter. The dimension available in the diagram, based on that we can decide it is we need 165 centimeter. PVC junction box 3-way we need 1 number. 4-way we need 2 numbers. So this is also 20 millimeter. The pipe is 20 millimeter, automatically junction box also 20 millimeter. Neutral link we need 16 ampere 240 voltage 1 number. Fuse unit 16 ampere 240 voltage 1 number. PVC box 4 into 4 inch 3 numbers are required. PVC insulated copper wire 1 square millimeter. 1 square millimeter is enough because we are using only one lamp at a time. That is required 165 centimeter. So this one decided based on the dimension available in the diagram. Steady batten holder 5 ampere 230 volt 3 numbers required. SPST switch, that is S1. S1 is the single pole single thrown on off, that is required 1 number. SPDT, the 3 terminals available, one is supply there, another 2 on and off, the 2 numbers required, S2 and S3. Then metal saddle we need 20 millimeter size 10 numbers. Then steel screw 13 into 4 millimeter 12 numbers, 25 into 6 millimeter 34 numbers, 38 into 6 millimeter 3 numbers. So these are all the requirements. So in this video we discuss about the go down wiring, operating the 3 lamp available in the go down according to our requirement. It can consider as 1 lamp is kept at the door, 1 lamp kept at the center, 1 lamp kept at the end of the go down. Those 3 are operated independently. Subscribe this channel for more electrical videos related to wiring and other topics. The material link is available in the description box. Thank you.